So, like I said, it was Independence Day weekend, so I didn't. I don't have much prepared to talk about today. Someone did this weekend over the weekend post a long tweet thread about sharding and how they think it isn't very effective, at least in terms of their experience with the LRON network. So I will write up a blog post to talk about the differences between that and the R-chain approach. So that's in the works. I've also been spending a lot of time thinking about, again, the biological aspects of the row calculus. In particular, one of the things that's really nice is that you can mimic in a fair degree of detail genetic structures. So in particular, you can start with that basic feature of being able to send code into a process, as data, send code as data into a process, and then let it run. And you can use that as the basis for a fairly high degree of mimicking of genetic, genetic transference of information. So I've been thinking about writing that up so that people can see how that works. I think for people with a little bit of imagination, it's not too hard to see how that might play out. But writing it up may expose some interesting equational aspects, some things that are properties that are preserved in doing it that way. So that's also in the works, but I didn't write anything up for today. Let's see, did we have other people join? Looks like it's just the 5 of us.
Yeah, I couldn't join immediately, so I'm not sure. Yeah,
no worries. Because I would like to reach out to both Arthur Grief and Raphael to see if they want to do blog posts. Also, Tomislav, if you'd like to do a blog post. I want to start getting more posts from other members of the co-op and the wider community. So it'd be really good if we can do that.
Yeah, I was talking to Nanzipper also to maybe we can, as a core developers, maybe we can also put some, knowledge and some information how we are doing and what we are doing. So
yeah, that would be great. Also, if you guys ever want to join the Q&A for the Chinese community, I'm sure they would appreciate that. It's all done via text. It's kind of like an AMA. So yeah, I think that might be it. Oh, cool. That'd be really good. I think they'd enjoy that as well.
Yeah, I'm definitely thinking about engagement with the community and to have more clear, so that they can have more clear a picture what we are doing and
Yeah, absolutely.
The things we are building.
Yeah, absolutely. I think they need to. The better we can communicate the picture, the more they'll be supportive. So absolutely. Okay, well, if there aren't any burning questions, Ian, if you want to go ahead and hit the send button, I can we can yield back the time today, and I'll just spend the between now and stand up reviewing that draft.
All right. Yeah, already sent, and I don't think it'll take you long.
Greg, can I ask just just a few minutes if you have time? So
Yeah, sure.
I'm interested. I was listening Eric Weinstein and his his lecture in Oxford a few years ago about his view on his proposal with spinors and 14 dimensions. So I'm wondering what do you think, and how
Oh, yeah.
we
Well,
can
I
maybe think
listen.
in rolling terms.
Well, I listened to the lecture. So the one thing I would say, just in general, of all of the physical theories to date, is none of those theories present or include a notion of agency. So one of the reasons I'm so interested in uh, the row calculus and the pi calculus and this whole family is that for the first time we have a mathematical theory of agency with a lot of moving parts, a lot of things that we know now we need to get right. Uh, or we have a template for what it means to get it right. So bisimulation is a really important part of that. Um, and the relationship between bisimulation and types is a really important part of that. So we can ask, when are two agents the same, or when are they doing the same job? And so there's a notion of agency. Like if you think about it, right? Like physicists don't talk about the purpose of the moon, right, or the purpose of the sun. They don't talk about that. That's not. There's no language inside either the the scientific language or the mathematical language for talking about things like purpose, telos, things like that. But by the time you get to bacteria, all right, it's really, really difficult with biological complexity not to talk about purpose and function. And but my sense is that it's not. We're not going to that there isn't any real tower of complexity. My sense is that there's a how do I say this? There's like a recursive relationship, right? The complexity that we find associated with biological systems is easily found in any of these theories, like whether it's string theory or loop quantum gravity or any of these others. They have the same level of computational complexity, and so they can support intelligence and affect and evolution. All of those things are available at the very fabric of space-time, just in terms of what's available computationally. And so when I look at any of these theories, if they don't have a built-in notion of agency, then I'm suspect. Now, what's interesting to me about because it's like you're not going to get it later. You have to have it kind of built in from the start. And that's why I'm interested in starting with theories of agency and seeing if I can build geometry. So turning the whole thing on its head, right? That's why I have pursued those kinds of things. Start with a theory of agency and then see if I can build build a notion of that corresponds to the kind of universe that we see. Now, what's interesting about Weinstein's theory is that he kind of places the tangent bundle and the space itself on equal footing. Now, that is a new idea. So he's like giving himself more wiggle room, and And so they're not new dimensions in the same way that string theory has new dimensions. He's sort of he's he's suggesting that we, if we're careful in our accounting, we can make, and this is more computationally savvy, right? You can make sort of both the apparatus that you're using to do things like measure curvature be on equal footing as the space where you thought things were taking, where you thought all the machinery was taking place, all the interesting stuff. He's saying it's not the case that all the interesting stuff is on the space. It's also on sort of the meta space, if you want to think about it that way. And that if you have both in play, then you can start to get, if you squint a little bit, you can start to see some things come into, you start to look unified. So that's an interesting idea. It's probably worth exploring. He has a lot of technical hurdles to overcome, and he admits that he has a lot of technical hurdles to overcome. But the kernel of the idea is quite interesting. So that's.
So, what I was thinking that now when he presented this lecture, he was like, no one think that this is like serious things, because he didn't present this in a paper with very like detailed description. So I'm thinking where he has a problem. So why he doesn't just write the program and say, yo, here's the program, you can run it, and there's the thing.
Oh well, no,
I mean,
no. He's doing much more classical mathematics, right? To do simulations of what he's talking, it's pretty far out to do simulations of what he's talking about. In the same way that it's really, solutions to the Einstein field equations are really tough. So he's basically providing, all he's doing. I mean, again, I'm not a physicist, and this kind of mathematics is not my bailiwick, right? I've bootstrapped, as much as I can, understanding of this kind of mathematics. But what I can say is he's taken the traditional framework and which took a long time to develop. Is the traditional framework of differential geometry, and it took a lot of insights by a lot of people to build up this framework. He just sort of reconceptualized it. He said, look, typically what people do is they put all the weight on the space and not on the tangent bundle, as if the tangent bundle were, a thing unto itself, as opposed to a tool to understand the space. He says, no, we should include the tangent bundle. We should include the sort of the meta space as where things take place. So he's sort of changing the ontological status of the machinery a little bit. So it's not as different as one might think from a classical approach. So that gives me a lot more interest in his approach as opposed to others. I think it's more interesting than a string theoretic approach, to be perfectly honest. So that's yeah. But all of these approaches, they lack a theory of agency. And I really think that it's super important to start with a theory of agency and then build your apparatus on top of your theory of agency. And this is definitely doable, definitely doable. We know it has to be doable, right? Because if we accept the modern idea of what is, you know, sort of computationally approachable, then if you have any sort of Turing complete system, you have to be able to write down all of the mathematics that you expect to be able to compute with inside that system. So that's go ahead.
So I'm thinking that can I see this as a, so we have one language for quantum mechanics and one language for general relativity, and they're not compatible directly, but we can lift this in another language which can unify both of these languages, right?
Yeah, yeah. I mean, that's the aim, is to find. And typically, what people have done is to either make general relativity bend, which is usually a bad idea, or to make quantum mechanics bend, which is also fraught. Yeah. So. Yeah. So I you know, how do I say this? If you, again, my intuition is if you want a scale invariant theory, you have to start with something that's scale invariant at the ground, from the ground. So there's something really important about, you know, Weinstein's insight, which is to make more of the apparatus be considered to be a part of the actual, more of the tooling to be considered to have physical import. That's a way of saying it. So the mathematical tools have more physical import. So if you were to start with something that's scale invariant, and anything that you can write down as a Levier theory, or you know, and therefore is a monad, is going to have this self-similar structure inside it. It's going to be scale invariant in that sense. It's going to evince some kind of self-similarity. So if you start there and you build your theory of geometry and forces and all that stuff on top of that, then it will already be quantized in a way that will sort of naturally fit with quantum mechanics. Now there are some tricky bits to quantum mechanics. In particular, entanglement is something that you have to be able to talk about. Now, intriguingly, it is possible to model things like entanglement in the pi calculus or the rho calculus. You can talk about systems that are like inseparable because they have a scope around them that that means they're connected by a certain kind of information. But making that line up with the axioms of quantum mechanics is a little bit trickier. So yeah, so there's a there's a lot of mathematical work yet to be done, but if my intuition says put the thing onto a foundation that is self-similar and has a theory of agency, and once you do that, then you'll get a better, you'll be on a more solid ground, I guess is the way I would put it. But again, the Weinstein's insight to make the tooling have more ontological status is I think a good one. I think it's definitely worth thinking about. I recently had a wild-eyed idea. I read a result in differential geometry that I had not understood before. So apparently, of all the n-dimensional vector spaces, four dimensions is singled out because rather than having a unique atlas up to diffeomorphism that makes it into a smooth manifold, a smooth structure, there are an infinite number of smooth atlases, smooth manifolds associated with it. So I thought that was really very strange. Like I could imagine a result that said, 4K dimensions, right? Something like that, or some relationship amongst the dimensions, but a single dimension, and it happens to be 4, gives you this infinite number of manifolds. That's very strange to me. That's incredibly odd. And it made me wonder if, because like when you have to ask yourself if there is such a, if there is such a thing as many worlds, and again, you have to be super careful about this. What's the container? What's the ontological status of the thing that contains all the different worlds, right? And so where do they? What kind of being does the container for all those universes have? And that's so it might be that there's something special about a 4-dimensional vector space that makes it an appropriate container for a multiverse. And again, this is entirely speculative thinking. I'm just having fun. I'm not saying that there's any solid math to this, but I was really struck by this result. It's like, wait a minute, this is very strange. Okay, I think it would be good to call it for today, and I'll have something a little bit more prepared for next week. All right, gentle people, I will see some of you in Dev Stand Up. Thank you all.
Okay,
Thank
great.
you.